Every decision you make might be creating another universe. This is the core of the multiverse hypothesis, a real scientific idea that proposes our reality is just one of countless others. By the end of this, you will fundamentally reshape your understanding of what is real. We will explore how ancient philosophy and modern physics collide on this topic, uncovering why some scientists believe an infinite number of you could exist right now. What does it truly mean to be you in a cosmos of endless possibilities? 93 billion light-years sounds impossibly vast, yet this is the boundary of everything we can ever know. We call this our observable universe, a colossal sphere centered on us, containing every star, every galaxy, and every photon of light that has had time to reach our telescopes since the dawn of time. The key word here is observable. It is not the entire universe. It is just our local neighborhood, the part of existence we are currently privy to. Everywhere we look, from the planets in our solar system to the most distant quasars, we see the same rules in play. Gravity behaves the same way, the speed of light is constant, and the same elements forge stars. This cosmic consistency is profound. It tells us that the physics governing our little corner is the same physics governing realms billions of light years away. But here is the mystery. Cosmologists have strong reasons to believe that the full universe, the true totality of everything that exists, extends far beyond what we can see. Our entire observable cosmos, with its 2 trillion galaxies, might be just a single bubble in an ocean of space. If the full universe is indeed infinite, then every possible configuration of matter, governed by our same laws of physics, must happen somewhere. This is the first quiet whisper of the multiverse. It suggests that our entire cosmic domain, everything we call home, could be just one island in an endless archipelago of reality. So what lies beyond the shores of our own observable island? Our cosmic horizon is a modern boundary, but the longing to look beyond it is ancient. Long before telescopes peered into deep space, philosophers were already contemplating the existence of other worlds. In ancient Greece, thinkers like Epicurus argued that there must be innumerable worlds scattered throughout the void, each with its own unique story. This was not a scientific theory in the modern sense, but a philosophical conclusion drawn from the idea of infinite atoms and infinite possibilities. Meanwhile, on the other side of the globe, Hindu and Buddhist traditions described vast cosmic cycles of creation and destruction, with countless universes arising and dissolving like bubbles on the surface of a boundless ocean. These were not mere myths, but sophisticated attempts to map the architecture of reality itself. The most dramatic chapter in this long history unfolded in the 16th century. A monk named Giordano Bruno dared to suggest that the stars were other suns, each potentially circled by its own inhabited planets. For this radical vision of a pluralistic cosmos, he was declared a heretic and burned at the stake. His story is a stark reminder of how threatening the idea of a larger reality could be. For centuries afterward, the concept of multiple worlds retreated from the scientific mainstream, lingering in the realm of philosophy and fiction. It was only in the 20th century, with the twin revolutions of quantum mechanics and Einstein's theory of relativity, that the multiverse found a new language. These powerful new tools of physics provided a mathematical foundation for what had once been pure speculation. The yearning to find our place in a grander scheme never faded. It simply waited for science to catch up. This historical thread connects ancient wonder to modern equations, showing that our current investigations into the multiverse are part of a timeless human quest. So what specific discoveries in modern physics finally forced scientists to take this ancient idea seriously? the strange behavior of the quantum world demanded a radical explanation. In 1957, a young physicist named Hugh Everett III proposed one so bold it was largely ignored for decades. He was grappling with the core weirdness of quantum mechanics, where particles exist in a blur of possible states called a superposition until the moment they are observed. The traditional explanation was that this cloud of possibilities collapses into a single reality only when someone looks at it. Everett found this idea messy and unsatisfying. What or who qualifies as an observer? Why does measurement have such a special power? His solution was breathtakingly simple and profound. He suggested that the collapse never happens at all. Instead, every time a quantum event presents multiple possible outcomes, the entire universe splits. In one branch, a radioactive atom decays. In another, it remains stable. The universe doesn't choose one possibility, it actualizes them all. This is the many worlds interpretation. It paints a picture of reality as a constantly forking path, a tree with infinitely branching limbs where every conceivable quantum event is realized. In one branch, a stray cosmic ray misses a DNA molecule in your ancestor. In another, it hits, altering your family tree forever. This interpretation does away with the need for a mysterious collapse, offering a completely deterministic picture of the cosmos. The sheer randomness we see is just an illusion, a consequence of our own position on a single branch of an unimaginably vast tree. It is a multiverse generated not by distant cosmic inflation, but by the ceaseless, minute decisions of reality itself, happening everywhere all the time. This theory provides a concrete, if controversial, mechanism for a type of multiverse, sprouting directly from the mathematics of our most successful physical theory. But if this branching is real, where are all these other versions of ourselves? Why does our branch feel so solid and singular? The quantum realm offers one path to parallel worlds, but there is another, born from the very origin of our cosmos. The theory of cosmic inflation describes a breathtakingly violent beginning. A fraction of a second after the Big Bang, our entire universe underwent an exponential growth spurt, inflating from a subatomic speck to a vast cosmic domain in an instant. This single burst of inflation gave us the large, smooth, and flat universe we observe today. Yet some of the most compelling models suggest this process was not a one-time event. It may be eternal. Imagine a boiling pot of water forever simmering. Our entire observable universe, with all its galaxies and stars, is not the pot itself, but a single bubble that formed, inflated, and stabilized within that eternal boil. We are one pocket universe in a much larger, eternally inflating meta-universe. In this chaotic landscape, new pocket universes are constantly bubbling into existence, each one a separate reality with its own unique properties. The fundamental forces in one bubble might be stronger. The number of spatial dimensions in another might be different. The very constants of nature, like the strength of gravity or the mass of an electron, could be set to random values in each new creation. This concept of eternal inflation paints a picture of a multiverse so vast and varied it defies human comprehension. It also offers a profound answer to one of cosmology's greatest puzzles, the fine-tuning problem. Our universe seems almost miraculously tailored for life. If the force of gravity were slightly stronger, the universe would have collapsed back on itself long ago. If it were slightly weaker, galaxies and stars would never have formed. In the eternal chaotic landscape, this is not a miracle. It is a statistical inevitability. In an infinite array of universes, most are sterile and stillborn. We simply find ourselves in one of the rare, fortunate pockets where the numbers randomly came out right for atoms, planets, and life to emerge. Our existence is not a planned outcome, but a lucky draw in a cosmic lottery of unimaginable scale. So if our universe is just one bubble among countless others, could there be a way to ever detect them? The most direct route to a multiverse begins with the sheer scale of our own cosmos. We have already established that our observable universe is just a tiny patch of a much larger whole. Now, let us follow that idea to its logical and deeply personal conclusion. If the full universe is truly infinite and the matter within it is distributed more or less evenly, then something remarkable must be true. With only a finite number of ways particles can arrange themselves, any possible configuration is bound to repeat across the vastness of space. This is the level 1 multiverse, and it is perhaps the easiest to accept because it does not require any new physics, only a straightforward application of probability to an infinite canvas. Think of it like a vast cosmic deck of cards. Shuffle a deck enough times and eventually you will get the exact same sequence twice. Now imagine an infinite deck being shuffled across an infinite space. Every possible hand will be dealt not just once but an infinite number of times. This means that somewhere far beyond the reach of our most powerful telescopes, there is another galaxy identical to our Milky Way. Orbiting an identical star is an identical Earth where a person exactly like you is sitting down reading these very same words. This is not a different universe with different laws. It is simply another region of our own infinite universe, so distant that its light will never reach us. Your doppelganger is not a ghost or a phantom, but a real person made of the same atoms, living a life that has, up until this very moment, been a perfect copy of your own. The divergence might happen in the next second, with a different thought or a different choice, creating two parallel histories from that point forward. In an infinite cosmos, every life you could have lived, every path you did not take, is being lived out by another version of you in a distant corner of reality. This is not science fiction, but a direct implication of our best models of the cosmos. So the next time you wonder about a road not taken, remember that in the grand cosmic scheme, you likely took them all. This branching of cosmic realities takes us to an even more profound frontier, a level 2 multiverse where the rules of the game themselves are rewritten. We are no longer just talking about infinite copies of our own universe with its familiar laws. Here, the very fabric of physics is different in every pocket. Imagine a vast cosmic laboratory where the fundamental constants are dialed to random settings in each new bubble universe. In one of these realms, the force of gravity could be significantly stronger. In such a place, stars would burn through their fuel with ferocious speed, collapsing into black holes long before planets could ever form. Life would be an impossibility. In another universe, the cosmological constant, which controls the expansion of space, might be set to a negative value. Instead of expanding forever, that entire cosmos would shudder to a halt and violently recollapse in a catastrophic big crunch, snuffing out any potential for complexity in a fiery instant. These are not mere variations on a theme. They are entirely different symphonies of existence, most of which would be silent and sterile. This staggering diversity provides a powerful answer to one of science's most perplexing mysteries, the fine-tuning problem. Our universe appears to be miraculously calibrated for life. The strength of gravity, the mass of a proton, the energy in empty space, every one of these numbers seems perfectly balanced on a razor's edge. If any of them were tweaked by even a tiny fraction, our cosmos would be a lifeless void. The level 2 multiverse offers a humbling explanation. There is no fine-tuning. We simply live in one of the exceedingly rare bubbles where the cosmic lottery happened to spit out a winning ticket. This line of thinking, known as anthropic reasoning, completely reframes the question. We stop asking why the constants are what they are, and start asking why we find ourselves in a universe that permits our existence in the first place. We are not the purpose of the cosmos, but rather its fortunate guests. So if the multiverse is real, spanning from quantum branches to cosmic bubbles with alien laws, what possible evidence could ever convince us we are not alone in existence? Our universe's specific laws of physics might simply be one possible setting on a cosmic dial. This idea finds a startlingly concrete form in string theory, a leading framework for a theory of everything. At its heart, string theory proposes that the fundamental building blocks of nature are not point-like particles, but unimaginably tiny, vibrating loops of energy. For this beautiful mathematics to work, it demands that space has more than the 3 dimensions we experience. The theory requires an additional 6 or 7 spatial dimensions, all curled up into a shape so small that we are completely unaware of them. The specific way these extra dimensions are folded and compacted is absolutely critical. It is this geometry that dictates the laws of physics we observe, setting the values for constants like the strength of gravity and the mass of an electron. Imagine a grand piano with an almost infinite number of keys. The way those keys are pressed determines the melody that plays. In string theory, the compactification of dimensions is like a specific chord, and that chord defines the entire symphony of a universe. The truly staggering discovery was that there is not just one way to fold these dimensions. Physicists have calculated that there could be 10 to the power of 500 different stable configurations. That number is so vast it defies all human analogy. It is more than the number of atoms in our entire observable universe. This is what scientists call the string theory landscape, a vast terrain of possible physical laws. Each point in this landscape is not a star or a galaxy, but an entire universe with its own unique set of rules. Our cosmos, with its particular constants perfectly suited for life, is merely one volume in an unimaginably vast cosmic library. We are not a special creation, but one mathematical possibility that happened to be realized, one book on a shelf that stretches beyond any horizon we can conceive. This landscape provides a potential physical mechanism for the Level 2 multiverse, rooted in the most ambitious attempt to unify all of physics. It suggests that the diversity of possible universes is not just a flight of fancy, but a mathematical prediction. So if our reality is just one page in an infinite book, what could possibly turn the page for us? This final concept pushes the very idea of existence to its absolute limit. Some thinkers propose that every mathematical structure, every coherent set of abstract equations, is not just a description of a universe, but is a universe in its own right. This is the mathematical universe hypothesis, a vision of a Level 4 multiverse so vast it encompasses all of reality. Our cosmos, with its galaxies and atoms, is not merely governed by mathematics. According to this radical view, our universe is mathematics. Your consciousness, the stars above, and the device you are using right now are all part of an incredibly complex mathematical object. We are not just players in a game with mathematical rules. We are living, breathing expressions of the rules themselves. This hypothesis shatters the final barrier between the abstract and the concrete. It suggests that a universe described by a different set of equations, one with 5 spatial dimensions or a completely alien form of logic, is just as real as our own. It simply exists in a different part of the mathematical landscape. Think of the number pi. It is an infinite, non-repeating decimal. It does not need to be written down or calculated to exist. Its properties are inherent and eternal. Now apply that same logic to a cosmos. If a self-consistent mathematical structure can be conceived, then it exists with the same stubborn reality as the number pi. This makes the multiverse not merely a physical possibility arising from quantum theory or cosmic inflation, but a logical necessity. The totality of existence is simply the complete set of all mathematical truths. This means the most exotic realities you could possibly dream of, worlds with floating castles made of pure thought or dimensions where time runs in circles, are not fantasies. If they are mathematically consistent, they are out there, as real as the ground beneath your feet. Our particular mathematical structure happens to be one that allows for conscious, self-aware substructures like us to emerge and ponder our own origins. We are the universe becoming aware of its own mathematical nature. So where does this leave our search for meaning in a cosmos of infinite possibilities? The information that defines your existence might be written on a distant, two-dimensional surface. This is the astonishing implication of the holographic principle, a concept that emerges from the deepest puzzles of black holes and quantum gravity. To understand it, picture a black hole. Nothing, not even light, can escape its immense gravitational pull. Yet, in the 1970s, physicist Jacob Bekenstein discovered that a black hole possesses entropy, a measure of its hidden information content. This was a profound clue that a black hole's interior information was not destroyed, but somehow preserved on its outer boundary, its event horizon. The universe, it seems, does not allow information to be truly lost. This led to the radical idea that all the information describing the three-dimensional volume inside a black hole could be perfectly encoded on its two-dimensional surface, like a cosmic hologram. The stunning leap was to propose that this principle might apply to our entire universe. The three-dimensional reality we inhabit, with its galaxies, planets, and the very device you are holding, could be a magnificent projection from a vast, two-dimensional film of information at the cosmic edge. Our rich sensory experience of depth, texture, and solidity would then be a grand illusion, a computational output generated from a fundamentally simpler, flatter reality. This principle scales up to the multiverse. In the eternal chaotic landscape, each bubble universe could be a separate hologram, a self-contained projection with its own unique encoding on its boundary. One pocket universe might project the laws of physics we know and love, while another, with a different informational code, projects a reality with 5 fundamental forces or fractal dimensions. This transforms the multiverse from a collection of physical places into a library of cosmic projections, each running its own unique simulation from a flat, informational surface. This idea forces us to confront a truly fundamental question. If our universe is a hologram, what is the nature of the projector? The answer may lie in the language of computation. Our reality may not be a solid, physical structure, but rather the result of an immense, ongoing calculation happening on the boundary of space. The solidity of the ground beneath your feet and the vastness of the night sky could be the output of this cosmic computation. The holographic principle does not just suggest new universes, it suggests that the very fabric of space-time is an emergent property, a secondary effect arising from something more fundamental, a dance of quantum information. We are left wondering if the ultimate nature of reality is not made of stuff but of pure, dynamic bits. 2 particles can be born together and then sent to opposite sides of the galaxy. Change the spin of one and its partner instantly reflects that change, no matter the immense distance separating them. This is quantum entanglement, a phenomenon so bizarre that even Einstein called it spooky action at a distance. It defies our deepest intuition about how the universe should work, challenging the very idea that objects are separate and local. There is no known signal, no beam of light or ripple in space that travels between them to carry the message. The connection appears to be instantaneous and fundamental. This profound mystery forces us to consider that our classical view of reality, where things are distinct and isolated, might be a comforting illusion. At its most fundamental level, the cosmos could be deeply intertwined, a single, unified whole that only appears fragmented from our limited perspective. So what does this quantum weirdness imply for the multiverse? The spooky connection might not be happening across a vast emptiness within our universe, but across the chasms that separate different universes themselves. In the many worlds picture, when a particle is measured and its properties are decided, the universe splits. But what if the entanglement itself is a thread that persists, not just within one branch, but between them? An entangled pair could be a single entity whose components are now spread across different branches of the quantum wave function. Their instantaneous communication would not be a signal traveling through space, but a correlation written into the very fabric of a higher dimensional reality. This idea extends even to the bubble universes of eternal inflation. The chaotic energy field that spawns new pockets might create connections between them, like roots linking trees in a forest. Influences could potentially tunnel between these realities, not as physical objects moving, but as quantum information transferring. This transforms our image of the multiverse from a collection of isolated, impenetrable spheres into a dynamic and relational network, a cosmic web where every part, every universe is subtly connected to the whole. The multiverse begins to look less like a disconnected archipelago and more like a single, breathing organism. If this is true, then the separation between you and a distant star, or even between you and another version of yourself in a different quantum branch, may be just another layer of a magnificent illusion. Our own awareness seems to be the anchor for a single reality, yet quantum physics paints a far stranger picture. The traditional view, known as the Copenhagen interpretation, places the observer in a position of strange power. Before a measurement is taken, a particle exists as a blur of all possible states, a probability wave. The simple act of looking, of making a measurement, is what forces this cloud of potential to collapse into one concrete fact. An electron was everywhere at once, and then suddenly, because you looked, it is in one specific place. This idea has troubled physicists for decades. What exactly counts as an observer? Is it a human being, a cat, a sophisticated machine? The line is hopelessly blurred, suggesting that consciousness itself might play a mysterious role in shaping the world. This is where the many worlds interpretation offers a dramatic alternative. In this framework, there is no magical collapse. The probability wave never shrinks to a single point. Instead, at the moment a quantum event presents multiple outcomes, the entire fabric of reality divides. The universe does not choose. It embraces every possibility simultaneously by creating new branches of itself for each one. In this breathtaking view, the act of observation is stripped of its special power. You are not collapsing anything. You are simply a conscious passenger on one specific branch of an endlessly forking path. Your awareness is tethered to a single thread in the cosmic tapestry, while countless other versions of you, born from every quantum decision, follow their own threads into different realities. This immediately forces us to confront one of the most profound questions we can ask. Are those other versions of us also aware? When the universe splits, does the conscious experience housed in your brain split into two separate streams of awareness? Or is your unique consciousness somehow bound to only one path, leaving the other versions as philosophical zombies, biological machines without an inner light? We do not have an answer. This is where the hard physics of the multiverse collides directly with the deep philosophy of mind. It suggests that our subjective experience, the feeling of being you, is not a passive ghost in the machine. It may be an active component of reality, a fundamental property that is woven into the very process of cosmic branching. Your sense of self, the continuous story you tell yourself about your life, might be an illusion created by your limited perspective. You only remember the choices that happened on your branch. You only experience the outcomes that define your history. But in the grand, multi-branched structure of existence, every possible version of your life is being lived out in full. The you that took that different job or said yes instead of no, or was born in a different century, is just as real as you are right now. They all possess the same conviction that their path is the only one. This idea merges the fate of the individual with the architecture of the cosmos, proposing that our inner world of thought and sensation is inextricably linked to the outer structure of an infinite reality. What does it mean to be an individual when you are, in truth, a multitude? A persistent and powerful criticism echoes through the halls of physics that the multiverse is not science at all, but philosophy in a mathematical disguise. If these other realities are forever sealed off from our own, causally disconnected by unimaginable voids, how could we possibly prove they exist? This challenge strikes at the very definition of what makes a theory scientific, which has traditionally required the potential for falsification through observation or experiment. Proponents of the multiverse, however, propose a different kind of evidence. They suggest we look for the fingerprints of a larger reality left on our own. The cosmic microwave background, the faint afterglow of the Big Bang that fills all of space, is a prime candidate. Its specific pattern of hot and cold spots, the tiny temperature fluctuations imprinted on the sky, could contain a telltale signature. If our universe collided with a neighboring bubble universe in the distant past, the energy of that impact would have left a distinct, asymmetric scar on this radiation, a kind of cosmic bruise that our telescopes might one day detect. Another clue lies in the value of the cosmological constant, the mysterious energy causing the expansion of our universe to accelerate. Its incredibly small, finely tuned value is a profound puzzle. The multiverse offers a compelling explanation that this value is random, and we simply live in a bubble where it is small enough to allow galaxies to form. The mere fact that this constant has a life-permitting value, when almost any other value would be catastrophic, is itself a form of indirect evidence within this framework. Even the successful formulation of a final theory, like a complete version of string theory, could be seen as support. If the core mathematics of such a theory inevitably predicted a vast landscape of possible universes, then the existence of a multiverse would become the most natural conclusion, not an added speculation. This ongoing debate forces a deep and necessary conversation about the nature of science itself. Must a theory be directly testable to be valid, or can its power to explain otherwise inexplicable facts about our own universe, its puzzling fine-tuning and strange constants, grant it a legitimate scientific status? We are pushed to consider whether predictive power and immense explanatory scope are themselves a form of evidence, especially when dealing with the ultimate frontiers of reality. The universe's constants are balanced on a razor's edge, a cosmic tightrope where the slightest deviation would render everything silent and sterile. Consider the force of gravity. If it were just a fraction stronger, the immense gravity would crush stars into black holes long before planets could ever coalesce. Their brilliant lives would be brutally short, snuffing out any chance for life to emerge. Now shift your focus to the weak nuclear force, the delicate mechanism that governs how particles decay and fuse. If this force were even marginally weaker, the fundamental process of hydrogen fusing into helium inside stars would fail. The furnaces that power the cosmos would never ignite, leaving the universe a dark, primordial soup of simple elements. This perfect calibration is not just for one constant, but for dozens of them. It seems as though the cosmos was meticulously designed for our existence, yet the multiverse hypothesis offers a profoundly different and perhaps humbling explanation. There is no designer, no grand plan. Instead, in an infinite or near-infinite ensemble of universes, the dials for physical constants are set to random values in every new cosmic bubble. The overwhelming majority of these realities are stillborn, universes where gravity is too strong, or nuclear forces too weak, or where space collapses instantly upon itself. In this vast and mostly barren landscape, a tiny fraction of universes will, by pure statistical chance, have all the knobs turned to the exact settings that allow for atoms, chemistry, stars, and planets. We, of course, find ourselves in one of these exceedingly rare and fortunate pockets. Our existence is not a miracle, but a selection effect. This is the Anthropic Principle in action. You do not observe a universe incompatible with your existence. You are a product of a universe that permits observers to arise in the first place. It turns a seemingly miraculous coincidence into a simple, statistical inevitability. The very fact that we are here to ponder the question of why the universe is so hospitable becomes the very evidence that it must be, at least in one place, within a much larger and more chaotic multiverse. This line of reasoning reframes our entire cosmic story. We are not the purpose of creation, but rather the lucky winners of the ultimate lottery, living in a universe that just happened to get the numbers right. The sheer scale of an infinite cosmos leads to a paradox so bizarre it could keep a philosopher awake at night. Given enough time, the random quantum jostling of particles in an empty void could, by pure chance, spontaneously assemble a fully formed, conscious brain. This freak occurrence would not be a brain born from a body or a life, but a solitary, self-aware mind that flickers into existence complete with a lifetime of detailed, but entirely false memories. It would remember a childhood, a family, the feeling of sunshine on its face, all fabrications generated in an instant. Scientists call these hypothetical entities Boltzmann brains. In an eternal or infinitely large multiverse, the odds of such a random fluctuation are infinitesimally small, but they are not zero. And when you multiply any finite probability by true infinity, the result becomes inevitable. These phantom minds would be produced in incomprehensible numbers, far outnumbering the relatively slow, orderly process of cosmic evolution that led to ordinary observers like you and me. This leads to a deeply unsettling statistical conclusion. If you were to randomly pick a conscious being from the entire ensemble of reality, you are astronomically more likely to be one of these momentary, disembodied fluctuations than a person with a real past and a real future. Your conviction that you are reading this script, that you have a history, could itself be the first and only memory of a Boltzmann brain that formed and dissolved a second ago. This thought experiment is not a proposal that we are actually such phantoms, but a powerful warning sign. It highlights a potential flaw in how we apply probability to infinite realities. If a theory of the cosmos predicts that disembodied brains floating in a void are the most common form of consciousness, then that theory is almost certainly wrong, or at least incomplete. Physicists are therefore forced to refine their models of the multiverse and cosmic inflation, searching for those that naturally guarantee a universe where ordinary observers who arose from billions of years of stellar and biological evolution are the typical result, not the astronomical exception. The Boltzmann brain paradox is a cosmic sanity check, forcing us to ensure our most ambitious theories of reality do not spiral off into logical absurdity. It grounds the grandest of ideas in a simple, haunting question: How can we be sure that our memories are real? A collision with another universe would be the ultimate cosmic event. Picture our reality as a single soap bubble drifting in a foam of countless others. If a neighboring bubble were to drift too close and touch our own, the energy released at the point of contact would be unimaginable, sending a shockwave rippling through the very fabric of our young cosmos. This is not science fiction, but a genuine prediction of eternal inflation. The aftermath of such a crash would not be a field of cosmic debris, but something far more subtle and enduring, a scar frozen in time. That scar would be written in the oldest light we can see, the cosmic microwave background. This faint glow is the cooled remnant of the Big Bang's fireball, a snapshot of the universe when it was just 380,000 years old. A bubble collision would have left a distinct signature on this celestial canvas, a nearly perfect circular pattern of slightly hotter or colder temperatures. It would be a cosmic bullseye, a fossilized imprint of a moment when another reality literally bumped into our own. For over a decade, teams of astronomers have been scouring the exquisite data from satellites like Planck, hunting for these ghostly circles in the sky. They have developed sophisticated algorithms to search for the specific statistical anomalies that a collision would produce. The search is incredibly challenging, like trying to find a single, unique fingerprint on the surface of the Earth. So far, no definitive, undeniable collision scar has been confirmed. Yet the very fact that we can look, that we have a concrete hypothesis to test, transforms the multiverse from pure metaphysics into a potentially testable science. The absence of evidence is not evidence of absence. It simply means the search continues with more refined tools and greater sensitivity. A future discovery would be one of the most profound in human history. It would be our first piece of empirical mail from another universe, a tangible message proving we are not alone in the grand scheme of existence. It would tell us that our cosmic home has neighbors, and that the great expanse of reality is far wilder and more crowded than we ever dared to dream. An infinite multiverse seems to promise every possible version of your life, but this infinite bounty comes with a profound mathematical curse. If everything that can happen does happen, and it all happens an infinite number of times, then the very idea of probability begins to unravel. Think about flipping a coin. In our world, we say it has a 50-50 chance of landing on heads, but in the multiverse, both outcomes occur, creating two new branches of reality. Now, if every quantum event spawns new universes, and the total number of universes is infinite, then there are an infinite number of worlds where the coin landed heads, and an infinite number where it landed tails. How can you possibly say one outcome is more likely than the other when both sets are equally infinite? This is the measure problem, a deep crack in the foundation of multiverse theory. It is the challenge of finding a sensible way to count the uncountable, to weigh one infinity against another. Physicists need a consistent measure, a kind of cosmic accounting system, to determine which outcomes are common and which are incredibly rare within the infinite ensemble. Without this, the theory loses its predictive power. It cannot tell us why we observe the specific quantum probabilities we do in our labs, or why our universe has the particular constants we measure. The problem becomes even more bizarre when you consider your own life. There are an infinite number of universes where you are a billionaire and an infinite number where you are destitute. If both groups are infinite, what does it even mean to hope for success? The solution is not to deny the infinities, but to find a way to compare their sizes. Some infinities are, in a mathematical sense, larger than others. Imagine the number line. There is an infinite number of whole numbers, 1, 2, 3, and so on. But there is a larger infinity between any two whole numbers, an infinity of fractions and decimals. The measure problem asks physicists to perform a similar trick with reality. They must determine if the collection of universes where the laws of physics allow for stars and planets is a larger infinity than the collection of universes that are empty voids. This is not just abstract number crunching. It is essential for the multiverse to be a scientific theory and not just a philosophical speculation. Until we can define a measure and show that our observed reality is a statistically likely outcome within the multiverse, the hypothesis remains untethered from the very evidence it seeks to explain. The infinite tapestry of existence may be real, but without a way to navigate its probabilities, we are lost in its boundless expanse. The simulation argument turns our cosmic perspective inside out. It proposes that our entire universe, and perhaps even the entire multiverse, is not the foundational layer of existence but a sophisticated simulation running on a computer of unimaginable power. This is not a new idea in science fiction, but philosopher Nick Bostrom gave it a startling statistical backbone. His reasoning is deceptively simple. First, assume that at least some advanced civilizations survive long enough to develop the technology to create incredibly detailed, conscious simulations of their ancestors. Second, assume that these civilizations have either the interest or the resources to run a vast number of these simulations. If both these premises are true, then the number of simulated minds would quickly become astronomically larger than the number of original, biological minds. Now, if you are a conscious being, you are therefore statistically far more likely to be one of those simulated minds than a mind in the original base reality. The sheer weight of numbers suggests we are probably living in someone else's creation. This idea dovetails perfectly with the digital physics version of the mathematical universe. If reality is fundamentally computational, if the cosmos operates on a set of rules that can be expressed as algorithms, then it is, in principle, programmable. The universe would be the ultimate processing unit, and the laws of physics are its source code. In this view, the multiverse is not a sprawling, natural wilderness of infinite bubbles and branches. It becomes a curated collection, a library of simulated realities running on a substrate we cannot perceive. Each pocket universe could be a separate server instance with its own uniquely tuned physical parameters. The fine-tuning of our cosmos is no longer a lucky cosmic lottery win, but the deliberate setting of a programmer. The strength of gravity and the mass of an electron are not random, they are design choices. This completely reframes our place in the grand scheme. We are no longer just lucky guests in a vast cosmos. We might be characters in an epic narrative whose purpose we cannot fathom. Are we part of a scientific experiment run by our distant descendants? Are we entertainment in a hyper-advanced civilization? Or are we merely background processes in a computational system built for a reason we could never comprehend? The line between the created and the creator blurs into nothingness. If we are in a simulation, then our entire scientific endeavor is the process of reverse engineering the source code of our own reality. Every physics experiment, every telescope observation, is an attempt to debug the program we are living in. This transforms the multiverse from a fundamental aspect of nature into a potentially engineered artifact, a product of information science rather than blind physical law. It forces us to ask what lies outside the simulation and whether our own future might one day involve building such realities ourselves. Your own life is a single thread in an infinite tapestry of lived experiences. The choices that define you, from the trivial to the life-altering, are not just mental events. According to the many worlds interpretation, they are physical events that cause the cosmos to split. When you stood at a crossroads deciding between two job offers or grappling with a difficult personal choice, the universe did not simply follow the path you selected. It followed both, A new branch of reality was created at that very moment, a permanent fork where another version of you, identical up until that point, embarked on the other path. This is not a metaphor. It is a direct consequence of applying quantum mechanics to the process of decision-making, where the neural activity in your brain is itself a quantum system. The you that chose to stay in your hometown and the you that moved across the country are equally real, each now living in a separate, non-communicating branch of the universal wave function. They are forever inaccessible to one another, yet they share a common origin in the person you were just before the decision was made. This idea fundamentally challenges our deepest intuitions about identity. We feel like a single, continuous self, a persistent I that moves through time. But if countless other versions of us are living out the consequences of every road not taken, what does that make the person you call yourself? You are not the only you. You are simply the one having this particular experience. This perspective can transform how we view regret. That painful memory of a missed opportunity or a poorly chosen word is not just a ghost in your mind. In another reality, a version of you seized that opportunity or remained silent. Every possible outcome is realized somewhere. This does not make your own struggles and joys any less meaningful. In fact, it makes your specific journey uniquely precious because it is the only one you will ever know. Your life is both cosmically commonplace, one of an infinite number of similar stories, and utterly singular from your own point of view. The multiverse, in this sense, is the most intimate of concepts. It is not just about distant bubbles of space with alien physics. It is about the quiet moments in your own past and the phantom echoes of your choices playing out in realities you can never visit, yet are forever connected to by the simple fact that they too are you. Our universe appears to be drifting. Across the deepest reaches of space, astronomers have mapped the motion of entire galaxy clusters, and they found something they never expected. These colossal structures, each containing thousands of galaxies, are not just moving apart with the general expansion of the cosmos. They are also streaming together in a specific, coherent direction, as if pulled by a cosmic tide. This mysterious phenomenon is known as dark flow. It is a subtle but persistent current in the cosmic ocean, and its source is a profound puzzle. The force required to move these galaxy clusters on such an immense scale must be unimaginably powerful, and it originates from somewhere beyond the edge of our observable universe, from a region whose light has not yet had time to reach us. One of the most compelling, though highly speculative, explanations is that the gravitational pull comes from a neighboring universe. Just as the moon's gravity tugs on our oceans to create tides, a massive structure residing in a separate bubble of reality could be exerting its own influence across the void, creating this strange, directional drift we detect from within our cosmic home. Other scientists propose more conventional causes, suggesting the dark flow could be a remnant of the violent, uneven conditions during the earliest moments of inflation. The evidence itself remains hotly debated, with some analyses supporting the flow and others finding no trace of it at all. Yet its very possibility forces a thrilling realization. The dynamics we observe within our universe might not be entirely self-contained. The border of our reality may be porous, allowing subtle influences to leak through from the outside. If dark flow is real, it is not just a curiosity. It is a potential fingerprint on a window, a smudge left by something vast and unseen pressing against the glass of our own spacetime. It suggests that the greatest mysteries of the cosmos may not be found by looking inward, but by deciphering the faint signals that hint at what lies beyond our own horizon. Our own minds are exquisitely crafted by the universe they are trying to comprehend. The language we speak and the logic we use evolved in a world of 3 dimensions, where time flows forward and gravity pulls things down. These tools are perfectly adapted for navigating the reality we call home, but they may be utterly useless for describing what lies beyond its borders. When we try to envision a multiverse, we are forced to use concepts like place, object, and event. But these ideas might have no meaning in a cosmos where the very fabric of physics is rewritten. How do you describe a realm where cause and effect are not linked, where an object can be in 5 places at once, or where existence itself is a transient property? We are like deep-sea fish that have evolved a sophisticated language to describe the pressures, currents, and creatures of the ocean abyss. We can speculate about dry land, but our words for wetness and pressure fail to capture the essence of wind or sunlight. Our brains, honed by millions of years of evolution in a very specific environment, may simply lack the necessary wiring to process a reality that operates on completely alien principles. This is the profound epistemological challenge of the multiverse. It suggests a humbling possibility that the ultimate nature of existence might be permanently walled off from our understanding, not by a lack of data, but by the intrinsic limitations of our own cognitive machinery. We are trying to read the cosmic library with an alphabet we invented for a single, solitary book. Some truths may be so foreign that our minds, brilliant as they are, cannot form the thoughts required to hold them. Long before physicists wrote equations for eternal inflation, storytellers were mapping the territories of alternate worlds. Ancient myths spoke of spirit realms and underworlds, parallel domains where different rules applied and other selves might dwell. In the 20th century, authors like H.P. Lovecraft crafted entire cosmologies of dreamlands, dimensions layered over our own, accessible only through forbidden knowledge or strange portals. These were not scientific proposals, but they tapped into a deep human intuition that our reality might not be the only one. Comic books took this idea and ran with it, creating sprawling narrative universes. DC Comics' Crisis on Infinite Earths was a landmark event, explicitly portraying a multiverse where countless Earths existed in parallel, each with its own history and its own version of classic heroes and villains. This was not just a plot device, it was a new mythology for the modern age, a way to explore endless variations on a theme. Today, this concept has exploded into the cinematic mainstream. Films like Spider-Man Into the Spider-Verse dazzle us with the visual poetry of countless spider people, each from a different reality, united by a common core of responsibility. Everything Everywhere All at Once uses the chaotic framework of the multiverse to tell a deeply human story about regret, family, and the search for meaning across a lifetime of choices. In these stories, the science is often secondary to the soul. The focus is not on the mechanics of universe hopping, but on the emotional consequences. What does it mean to be a hero when infinite versions of you exist? How do you find purpose when every choice branches into a new reality? These narratives explore the personal weight of infinity, something that dry equations cannot easily convey. They serve as a vital cultural and psychological bridge. By familiarizing us with the sheer strangeness of multiple realities through character and story, they gently prepare our collective imagination for the far more radical and potentially real possibilities that cosmology is now unveiling. Fiction gives us a language and an emotional framework for a concept that might otherwise be too abstract and terrifying to confront. It allows us to practice, in a safe space, what it might feel like to truly not be alone in the universe because we are surrounded by an infinite number of ourselves. This branching of realities forces a deeply uncomfortable question about the nature of right and wrong. If every possible version of you exists across an endless multiverse, does any single choice you make truly matter? In one branch of reality, a version of you performs a heroic, selfless act. In another, a version of you commits a terrible crime. Both events are equally real in the grand scheme of existence. So, are you responsible for the actions of these other selves? The very foundation of our ethical systems, built on the idea of individual choice and consequence, begins to tremble. One compelling argument is that morality is fundamentally local. It is anchored to the specific, conscious experience of the person you are in this very moment, on this single branch of the cosmic tree. Your sense of right and wrong, your feelings of guilt and pride, are tied exclusively to the choices made by the version of you having this experience. The other versions are philosophically separate entities, their paths diverged, their moral accounts their own to settle. Yet another perspective suggests that if the multiverse is a single, interconnected structure, a sense of broader responsibility might be inescapable. While you are not personally culpable for a crime committed in another reality, the knowledge that such a potential exists within the broader pattern of you could impose a different kind of duty. It might compel you to strive toward being the best possible version of yourself in this reality, as if your choices here could somehow honor or counterbalance the infinite spectrum of your other lives. This is not about punishment or reward, but about cosmic alignment. This debate pushes us to re-examine the purpose of ethics itself. Are moral codes merely practical guides for a single, isolated society, or do they reflect deeper truths about value and existence that might hold across the entirety of reality? The multiverse does not necessarily erase morality, but it stretches its meaning to a breathtaking scale, challenging us to consider whether our actions are significant precisely because they define our unique thread in an infinite tapestry. The quest for a single, elegant equation to explain everything might be fundamentally incomplete. For centuries, physics has been driven by the dream of a final theory, a perfect set of laws that uniquely describe our cosmos from the smallest quark to the largest galaxy cluster. This theory of everything would be the ultimate answer, the master key to all of reality. Yet the multiverse hypothesis suggests a radically different path forward. It proposes that there is no single key because there is no single lock. Our universe, with its specific, life-friendly laws, may be just one possibility in a vast statistical ensemble. This is not a small adjustment. It is a revolution in perspective as profound as realizing the Earth is not the center of the solar system. Instead of asking why the laws of physics are what they are, we would be forced to ask why we find ourselves in this particular universe within the wider multiverse. The focus of physics would shift from prediction to statistics, from finding the one true melody to mapping the entire possible landscape of symphonies. The ultimate reality would not be a unique set of equations, but a cosmic distribution of possibilities. Our familiar laws of physics would be demoted from fundamental commandments to local bylaws, effective rules that hold only within our particular cosmic neighborhood. The future of fundamental physics then splits into two diverging roads. One path continues the search for a unique theory of everything, perhaps through string theory or another framework, holding onto the belief that elegance and uniqueness must be the hallmarks of ultimate truth. The other path embraces the multiverse, accepting that the deepest level of reality is a vast and perhaps untidy landscape of possibilities. In this future, physicists would become cosmic cartographers, charting the terrain of possible universes and calculating the probability of finding a universe like our own. The question is no longer what the universe must be, but what it can be. Are we on the verge of a grand unification or standing at the brink of the most profound paradigm shift in the history of science? This macabre thought experiment pushes the logic of branching realities to its absolute limit. A gun is pointed at your head, but its trigger is linked to a quantum event, perhaps the decay of a single radioactive atom. In the next second, the universe splits. In one branch, the atom decays and the gun fires. In another, it does not, and you remain alive. From the outside, an observer would see you die in roughly half of all resulting branches. But from your perspective, something profoundly different happens. In every single branch where the gun fires, your consciousness is instantly extinguished. You are not there to experience that outcome. The only branches you can ever be aware of are the ones in which you survive. With each successive trigger pull, the same division occurs. You will always and only find yourself in a reality where the quantum dice have rolled in your favor. To your continuing consciousness, it would appear as though you are miraculously immortal, repeatedly cheating death against impossible odds. This is the unsettling paradox of quantum suicide. It is a purely theoretical scenario, one that is ethically unthinkable to ever test, yet it serves as a powerful lens on the nature of self. Your conscious experience is not a bird's-eye view of the entire multiverse. It is a flashlight beam illuminating only a single, narrow path through the infinite forest, a path that, by its very nature, must be one you can walk. This forces a stark distinction between the objective reality of the multiverse, where you die in countless branches, and your subjective reality, which is perpetually anchored to a timeline where you persist. The experiment suggests that from a first-person perspective, in a many-worlds reality, you might be functionally immortal not through magic, but through a continuous, unconscious selection process. You are not a fixed entity moving through time, but a flowing point of awareness, forever skimming along the surface of a reality tree, always finding itself on a branch that continues to grow. The branch of reality you call home feels solid and singular, but the quantum math suggests it is just one thread in a tapestry of infinite possibilities. So why do you experience this specific thread and not another? This puzzle is known as the preferred basis problem. The equations of quantum mechanics describe a world of overlapping potential, a shimmering fog of what could be. Yet we never perceive that fog. We only ever see one definite outcome at a time. What or who chooses which outcome becomes our reality? One radical answer points directly to us. Some interpretations of physics propose that consciousness is not a passive bystander, but the very mechanism that crystallizes reality from the quantum haze. In this view, your awareness is not merely receiving a pre-recorded movie of the universe. It is actively projecting the film. Every time you look at something, you are not collapsing a probability wave. You are selecting a single, stable timeline from an infinite stack of overlapping possibilities. This idea ventures far beyond conventional science into the realms of panpsychism and idealism. These are ancient philosophies being revived by modern physics. Panpsychism suggests that consciousness is a fundamental and ubiquitous property of the universe, as intrinsic to matter as mass or charge. A rock may not think, but it possesses some minute, primitive form of inner experience. Idealism goes even further, proposing that mind is the ultimate foundation of everything. The physical world, with its galaxies and atoms, is a manifestation of a deeper mental reality. In such a cosmos, the multiverse is not a collection of physical places, but a realm of pure potential. Your conscious observation is the process that weaves one consistent history from this boundless potential, stitching together a past, a present, and a future that make logical sense to you. This makes you far more than just an inhabitant of the cosmos. You are a co-creator of your own cosmic story, an active participant in the ongoing creation of reality, moment by moment, decision by decision. Your life is the universe waking up to itself, one conscious observation at a time. The serene darkness of a black hole's event horizon hides a violent contradiction. According to Einstein's general relativity, crossing this boundary should be an uneventful passage, a point of no return where the immense pull of gravity feels like a smooth, if relentless, descent. Yet quantum mechanics, our most successful theory of the small, insists that information can never be truly destroyed. Every particle that falls in carries data, a unique identity that should, in principle, be preserved. So what happens to that information when it is pulled into a black hole that eventually evaporates, leaving behind only featureless radiation? This is the information paradox, a fundamental clash between our two greatest descriptions of reality. One solution, as shocking as the problem itself, is the firewall paradox. It proposes that the event horizon is not a tranquil gateway, but a searing wall of high-energy particles, an inferno that would instantly incinerate any object attempting to cross. This firewall resolves the information puzzle by ensuring the information is scrambled and reflected back out as the black hole evaporates, but it does so by shattering Einstein's elegant picture of smooth spacetime. We are left with a stark choice: either general relativity fails at the horizon, or quantum mechanics is wrong about information. Perhaps there is a third, more profound way out. Physicist Leonard Susskind and others have suggested that the information is not destroyed at all, but performs a kind of cosmic sleight of hand. From the perspective of an outside observer, the information never actually crosses the horizon. It is smeared and encoded onto the two-dimensional surface of the black hole like a hologram, but from the perspective of someone falling in, it does cross. The only way both these stories can be true without violating quantum law is if the information is duplicated, and the no-cloning theorem of quantum mechanics strictly forbids such duplication within a single universe. The solution, then, must involve a multiverse. When an object falls toward a black hole, the universe itself splits. In one branch of reality, the information is incinerated at a firewall, preserving the view from the outside. In another branch, it passes smoothly through the horizon, preserving the view of the falling astronaut. Both histories are real, but they become completely separate, non-communicating realities. The black hole acts as a cosmic fork in the road, not just for matter, but for the fabric of spacetime itself. This means the most destructive objects in the cosmos could be creators, endlessly giving birth to new universes with every bit of information they consume. The event horizon is not an end, but a beginning. Quantum field theory gives us our most precise calculations for the behavior of the subatomic world, yet it makes a prediction about empty space so spectacularly wrong it defies comprehension. The equations suggest that the vacuum of space should be boiling with a ferocious, repulsive energy, a force so powerful it would have torn our universe to shreds in the first fraction of a second. The predicted strength of this vacuum energy, what we call the cosmological constant, is a number with 120 zeros after it. The value we actually measure from the gentle acceleration of the cosmos is not just a little smaller. It is that unimaginably huge number divided by a 1 with 120 zeros after it. This is not a minor rounding error. It is the most embarrassing failure of prediction in all of science. How can our most successful theory of the small be so catastrophically incorrect about the large-scale structure of reality? The multiverse offers a breathtakingly simple escape from this logical prison. If the cosmological constant can take on random values across the infinite landscape of bubble universes, then the vast majority of these realities would be uninhabitable voids, either ripping themselves apart instantly or collapsing back on themselves before a single atom could form. In this cosmic lottery, a universe with a cosmological constant of precisely zero would be strange enough, but we do not even have zero. We have a value that is incredibly tiny, yet just large enough to drive the late-time acceleration of the universe without preventing galaxy formation in its youth. We do not live in a universe with a special, uniquely determined cosmological constant. We live in the only kind of universe we could possibly live in, one where this number fell within the narrow, habitable window. This is the Anthropic Principle in its most powerful form, using the conditions for our own existence to explain a physical parameter that otherwise seems like a monstrous coincidence. The multiverse does not solve the mathematical problem of why the number is small, but it dissolves the philosophical problem of why we observe it to be small. Our presence here acts as a filter, selecting our reality from an endless sea of impossible worlds. Our reality might be a single page in a much larger cosmic book. This is the startling vision of brain cosmology, a model born from the depths of string theory. The name comes from the word membrane, shortened to brain. It proposes that the four-dimensional universe we know, with its 3 dimensions of space and 1 of time, is not the whole story. Instead, our entire cosmic domain could be a 3-dimensional brain, a kind of island or slice, adrift within a higher dimensional space called the bulk. We are trapped on this slice, unable to perceive the full expanse of the bulk, much like characters drawn on a sheet of paper would be unaware of a 3rd dimension. The truly mind-bending part is that our brain is likely not alone. There could be countless other brains floating in this bulk, each one its own separate universe, perhaps just a microscopic distance away in a direction we cannot point to. Each of these parallel brains could have its own unique physics, its own history, and its own forms of life, all completely isolated from our own. The forces that govern our daily lives, like electromagnetism and the nuclear forces, are like ink that is permanently stuck to our page. They cannot leak off our brain into the bulk, which is why we have no direct way to interact with or detect these other universes. There is one crucial exception, however. Gravity, the force that shapes the cosmos itself, is different. It is so fundamental to the geometry of space-time that it can seep across the gap between brains, bleeding from our slice of reality into the higher dimensional bulk. This could explain why gravity is so incredibly weak compared to the other fundamental forces. We are only feeling a tiny fraction of its full strength, with the rest of its influence dissipating into the unseen dimensions around us. The implications of this model are profound. It provides a concrete geometric picture for a level 2 multiverse, where other realities are not infinitely far away in our own space, but tantalizingly close in a direction we cannot access. This setup also offers a dramatic explanation for the origin of our universe. If another brain universe were to drift too close to ours in the bulk, the resulting collision would be an event of unimaginable energy. The titanic release of force could have been the trigger for our own Big Bang, setting our cosmic history into motion. In this view, our entire universe may have been born from a shattering impact with a neighboring reality, a ghostly sibling we can never see but whose ancient touch brought everything we know into being. A particle's past can be rewritten by its future. This is the unsettling reality revealed by the delayed choice quantum eraser experiment, a setup so strange it seems to violate causality itself. In this experiment, a single photon is sent toward a screen, but its path is not predetermined. It exists as a wave of possibilities until it is detected. The twist comes from a choice made by a scientist after the photon has already hit the detector and its journey is, by all classical accounts, over. The experimenter can choose to either measure which path the photon took, forcing it to have been a particle, or to erase that path information, allowing it to have behaved as a wave. Astonishingly, the choice made in the present dictates how the photon behaved in the past. Its history is not fixed until it is observed, even if that observation happens after the fact. This apparent backwards-in-time influence called retrocausality feels like magic, a paradox that twists our understanding of time into a knot. Yet within the infinite corridors of the multiverse, this paradox finds an elegant resolution. There is no spooky action reaching into the past. Instead, the moment the scientist makes a choice, they are not changing history, but simply selecting which branch of history they have always been on. The photon did not have one past waiting to be edited. It had every possible past, a superposition of all potential histories, existing simultaneously across different branches of reality. In one branch, the photon traveled as a particle, and the scientist chooses to measure it as such. In another branch, the same photon traveled as a wave, and the scientist chooses the eraser setting. Both entire timelines, from the photon's emission to the scientist's decision, are equally real. The eerie feeling of retrocausality is just an illusion, a side effect of our conscious awareness being pinned to a single, consistent thread in the cosmic tapestry. We only become aware of the correlation between the present choice and the past event when they align on our branch, creating the powerful but false impression that the present reached back and molded the past. The experiment does not prove that we can change what already happened. It proves that what already happened was never a single thing to begin with. Your present does not create your past, it simply discovers which past you have always been living. The profound silence of the cosmos is its own kind of mystery. With countless stars in our galaxy alone, the universe should be teeming with civilizations, yet we hear nothing. This is the famous Fermi paradox, and the multiverse offers a startlingly simple, if lonely, explanation. We are not looking at a universe that is fundamentally built for life. We are looking at the one rare universe out of an infinite number of sterile ones where the numbers randomly came out right. In the overwhelming majority of cosmic bubbles, the constants are set to values that prevent planets from forming, or stars from burning long enough, or complex chemistry from ever arising. The silence is not a sign of our insignificance, but a testament to our incredible luck. We exist in a cosmic oasis, a tiny island of habitability in a desert of silent, empty realities. This perspective completely reframes the paradox. The question is not where everybody is, but why we are here at all. Shifting to the quantum multiverse, the answer becomes even more personal. Every possible outcome of humanity's future among the stars is realized across the branching wave function. In one set of realities, our first radio signals are answered by a welcoming committee, and we join a galactic community. In another vast set of branches, our signals are met with a weapon that erases our planet from existence. There are branches where we are the first intelligent life to arise, and branches where we are the last, finding only ruins. Our specific timeline, the one where we hear only silence, is not the definitive story of the cosmos. It is merely our local experience, a single thread in a tapestry woven with every possible outcome of first contact. The quiet sky above is not empty. It is simply the view from our particular branch of reality, a branch where, for now, we are alone with our thoughts, listening for a signal that may be echoing through countless other worlds we can never see. Your own reflection stares back at you from a distant universe. This is not a mirror, but a perfect copy born from the infinite shuffling of matter in a level 1 multiverse. This being shares your exact atoms, your memories, and the very thoughts you are having at this precise moment. Yet, the moment after you both finish this sentence, your experiences will begin to diverge. A stray thought, a different choice of word, an unexpected sound, and your histories will split forever. So, which one is the real you? Philosophy has wrestled with the nature of personal identity for centuries, but the multiverse inflates this puzzle to a cosmic scale. One classic argument states that you are defined by a continuous stream of consciousness. This stream is unbreakably tied to the specific branch of reality you inhabit. From this perspective, your cosmic twin is a separate individual from the very first moment of divergence, because their conscious experience is now their own, forever isolated from yours. They are a philosophical stranger who happens to share your entire past. But what if identity is not about consciousness, but about the pattern that creates it? If you are fundamentally the unique arrangement of information that constitutes your mind and body, then that exact pattern, when replicated, is also you. In this view, there is no single, privileged self. There is only the you pattern, instantiated across multiple realities, each instance having an equal claim to the identity of you. This becomes even more unsettling in the quantum many-worlds picture. Every few moments, a new branch splits off, creating a nearly identical version where a single quantum outcome was different. Are you and this new branch a single individual that has now fractured into two? Or were you always two separate entities that simply shared a common past up until that fork in the road? The concept of a singular, persistent self begins to fray at the edges. It suggests that the you reading this is not a fixed point sailing through time, but a temporary knot in a web of endless possibilities. Your profound feeling of being a unique individual may be a necessary illusion, a cognitive shortcut that allows your branch-specific consciousness to function without being overwhelmed by the sheer weight of its own infinite echoes. In a cosmos of endless duplication, the most intimate truth you possess, your own selfhood, might be the most common thing in existence. The faintest whisper from the birth of the cosmos could reveal its true, infinite nature. This whisper is not a sound, but a ripple in the fabric of spacetime itself, a primordial gravitational wave. These waves are theorized to have been generated in the universe's first violent fraction of a second, during the period of cosmic inflation. If we could detect their specific signature, it would be like finding the fossilized imprint of creation. The most promising place to look for this ancient fingerprint is in the cosmic microwave background, the oldest light in the universe. As this light traveled through the infant cosmos, the stretching and squeezing of space by these primordial waves would have left a distinct curling pattern in its polarization, a signature scientists call B modes. Finding this pattern is one of the most important goals in modern cosmology. Its detection would be the most direct evidence we have that cosmic inflation truly happened, that our universe underwent that exponential growth spurt. And since eternal inflation is a primary engine for generating a level 2 multiverse, confirming the parent theory dramatically strengthens the case for that vast cosmic ocean of bubble universes. The hunt for these B modes has been a dramatic saga. Initial, exciting claims of a detection were later shown to be contaminated by interstellar dust within our own galaxy. It was a sobering reminder of how difficult this search truly is. Yet the quest continues with more powerful and precise instruments, like the Simons Observatory, which scans the pristine skies of the Atacama Desert. These experiments are not just looking for a ripple, they are searching for a cosmic arrow pointing beyond the confines of our single universe. A confirmed detection would do more than tell us how our own bubble began. It would provide a crucial piece of evidence, a tangible clue that our reality is just one spectacular event in an eternal, inflationary meta-universe that is constantly spawning new worlds. The silence we have so far encountered is not a denial, but an invitation to listen more closely to the echoes of infinity. Our own cosmic story seems to be heading toward a quiet, frozen finale. Billions of years from now, the last stars will flicker out, and the universe will expand into an ever colder, ever darker void. This is the heat death, a state of maximum entropy where energy is evenly distributed and no more work can be done, no light can shine, and no thought can occur. It is the ultimate end of activity, a final, silent equilibrium. Yet this bleak fate might only apply to our single cosmic bubble. Zoom out to the scale of the multiverse, and a very different, far more vibrant narrative emerges. In the eternal chaotic landscape, the process of inflation never stops. While our pocket universe cools and stretches toward silence, new bubbles are continually being born in the frenetic energy of the meta-universe. Each one is a new beginning, a fresh universe with its own laws and its own potential for stars, life, and mind. This is cosmic recycling on the grandest possible scale. One particularly elegant model, called conformal cyclic cosmology, proposes that the end of our universe is not a true end at all. As space expands over trillions of years and particles lose their mass, the universe becomes an endless, cold, and empty sea of pure radiation. At this point, the distinction between a vast, empty end and a new, dense beginning vanishes. The universe, in its highly symmetric, featureless state, can be mathematically conformed or reshaped into the hot, dense singularity of a new Big Bang. The end of one cosmic cycle becomes the seamless beginning of the next in an endless, timeless loop. From the multiverse perspective, the entire life of our universe, from its fiery birth to its cold death, is just a single season in an eternal cosmic series. The grand story of cosmic evolution transforms from a single, tragic play with a final curtain call into an infinite, cyclical epic of creation, transformation, and renewal. The silence of our future heat death is not an absolute end, but merely the quiet moment between the breaths of a much larger, breathing reality. Our journey through the multiverse has stretched from the quantum split of a single particle to the birth of entire cosmic realms, forcing us to question the very nature of reality and self. This grand idea, while hovering just beyond the reach of direct proof, provides a stunningly elegant framework for some of our most profound puzzles. It explains the miraculous fine-tuning of our universe not as a divine act, but as a simple statistical necessity in an infinite ensemble. It resolves the spooky paradoxes of quantum mechanics by suggesting that every possible outcome is realized somewhere. The multiverse challenges the classical scientific ideal of a single, unique theory of everything, proposing instead a vast landscape where our local laws are merely one set of bylaws among countless others. This is not a retreat from science, but an expansion of its horizons, pushing us to consider new forms of evidence and new definitions of what is real. Whether this cosmic plurality is physically true or remains a powerful metaphor, its value is undeniable. It enriches our cosmic story, humbles our place in the grand scheme, and ignites our imagination like few other concepts can. The exploration of these infinite possibilities is far from over. We would love to hear your thoughts on this mind-bending topic in the comments below. If you enjoyed this journey to the edge of understanding, subscribe for more and never stop looking up at the stars, wondering what other versions of reality might be looking